This is the 0.96-inch OLED display. It has a resolution of 128 by 64 pixels. It uses the SSD 1306 driver and these two pins for communication, SCO and SDA. It's very common and it's easy to use because of its two-pin communication. But another common display also is the 0.91-inch display. It has a resolution of 128 by 32 pixel and it uses the same driver and same communication pins. But if you need something smaller, there's another display. It's a 0.49-inch. It has a resolution of 64 by 32. It uses the same driver and has the exact same pins for communication. In this video I'll show how to wire it up using either an Arduino Uno R3 or an ESP32. And in the end we will do a speed comparison between the Arduino Uno and the ESP32. Starting with the Arduino Uno, you need the Arduino Uno, the display, a breadboard, and some jumper wires. First place the display onto the breadboard, leaving space for the jumper wires. Then we will first connect power. It's either 5 volts or 3.3 volts. I will connect 5 volts to the second pin of the display, ground to the first one from the left, then SCO goes to A5, analog 5, and SDA goes to A4. I will get my cable for programming here and we will move on to the computer. Here in the Arduino IDE you need to install some libraries. We go to libraries and search for the SSD 1306 driver. It's by Adafruit. You have to install it from here. You also need the Adafruit GFX library and install it once again. Then we can go to Files, Examples, SSD 1306, and select the 128 by 64 I2C. This is a test sketch from Adafruit, but we need to change one thing. The screen address needs to be 3C and not 3D. Also, the screen width and screen height, as you can see, are 128 by 64. Even though our display uses the resolution of 64 by 32, but the SSD 1306 driver doesn't support that resolution. And what it does is just utilizes the lower center part of display. So we need to set the full resolution and just modify our code to work with that. Now I will not be modifying this whole code. I'll show how to upload it and you'll see what I mean that it uses the lower center part of the display. Okay, first you need to connect the Arduino. Then in my case it gets recognized, but if it hasn't gotten recognized for you, you'll need to find the serial port that says USB and then search for the Arduino Uno. You need to select it, click OK, and it should be bolded, Arduino Uno. Now we just hit the upload. After the code uploads, we can see just part of what is supposed to be seen. And here's what it's supposed to look like. Let me reset both of them. You can see that it uses only the lower centered half of the display. So how can we use the display then? Well, it's pretty simple actually, and here I've made a sketch. We need to include the wire library, the Adafruit GFX library, and the Adafruit SSD 1306 library. We utilize the screen here with the screen width, screen height, the wire library, and this is the reset pin. Since our display doesn't have one, we set it to -1. We initialize the serial, and this code here is optional, but if you have a problem with the screen, you can add it, and the code will check if you have the right address, because in some cases the address might be with D. Here in the loop is actually the important part. First we need to clear the display, then set the text size to 1. You can set the text size from 1 to 4 for the display. The set color to white, because we don't have any other colors. And we need to set the cursor. Now, since we use only 64 by 32 pixels, we need the image to be displayed 32 pixels to the right and 32 pixels down. So it starts at the top left corner of our display. And here's the text that you want to print. Display is the function that actually prints what you have taught to display, and we have a 1 second delay to cycle in the loop. Now if you upload the code, you can see that it's perfectly displayed on the display, and we have 4 lines with size 1, 2 lines with size 2 text, and only 1 line with size 3 text. And to really understand this, I will put this 0.96 inch display on the place of the 0.49 inch. After we set it, as you can see, the text is displayed on the lower center part of the display. Now for the ESP32 I have already connected it, but let me explain. Using these jumper wires here and here, I have connected the power supply to the power line. We have ground going to the first pin from the left, and 5 volts, or in our case 3.3 volts because the ESP works with that, to the second line. Then we need to connect the communication pins, the SDA and STL. First is the SCL, which is the third pin from the left, which goes to pin 22 on the ESP. Then is the SDA with the yellow wire, which goes to pin 21. Now if we connect the display and power it on, we can see that it works. Now I will not be trying to upload the same code, but to get the point, you need exactly the same libraries, and you need to set up the ESP32 core so that you can upload code to it. And now, as I promised, let's do a speed comparison between the ESP32 and the Arduino Uno. The ESP32 works on 240 MHz and the Arduino Uno works on 16 MHz. Which one do you think is faster? Well, of course it's the ESP32. It has a dual-core processor and works on a much higher frequency than the Arduino. If you enjoyed this video, please like it, and if you want to see more videos like this in the future, please consider subscribing. See ya, bye!